All right, what's good, y'all? Link here, and let's go for another daily legal question. Question 3085, minimum deletions to make string case special. I actually tried this one early today, but I was having some issue with my camera, and I also wasn't able to solve it. I got pretty close though, but I ended up looking at the solution, but I was really close. I'm gonna go through my thought process at a time, and then try to finish. I haven't done this one yet, so. Over here, you can see, as you can see, I tried it once with the, yeah, I was pretty much just counting the frequency, but I'll go over again. Okay, let's see. Okay, so you're given a string word and an integer k. We consider word to be k special if the frequency of word index I minus frequency of word index j, and the absolute value of that is less than or equal to k for all indices I and j. Here, frequency denotes the frequency of the character. Da, da, da. Okay, return the minimum number of characters you need to delete to make word case special. So in this case, we have k is equal to 0. We have the output is equal to 3 because the best case here will be removing the c, right? And then removing an a and another a. And then we have b, b, a, a. So frequency of a is equal to 2, b frequency of b is equal to 2 as well. So that matches k. And then like, of course, let's say if the frequency of a is equal to 4, the frequency of a minus frequency of a will always be 0. So don't have to worry about that. So my initial idea over here, let me take a screenshot of this. Okay, so my initial idea was to okay, so we only have to return the minimal numbers of operation we need to make, right? So because of that, we don't need to actually worry about the order of the letters. So the first thing I thought was like, okay, so if we don't have to worry about the order of the letters, let's make just a frequency count, right? Because I mean that's what we're gonna use at the end. So A is gonna have a frequency of 4, B is gonna have a frequency of 2, and then C is gonna have a frequency of 1, right? Okay, make sure 4, 2, 6, 1, 7. So 1, 2, 3, 4, 5, 6, 7. Okay, and then we have K is equal to 0. But my initial idea over here was like, okay, so let's say so we have 1, 2, and then 4. Uh, so for each element, yeah. So my first idea was like, okay, so let's say 4. We start like kind of like a dynamic programming approach and doing top bottom. So we start at 4. We have this one at 0, and then we check now over here at 2, right? So 2, we can either delete 2, or we can keep 2 and then take the difference, right? So if we remove 2, that would be 2 operations, and then if we don't remove 2, we have to match the frequency of the previous one, which is always going to be 2. So in this case, the best option here is 2. Now for the 1, what I thought at the time was like, okay, so I can either compare myself with 2, or I compare myself with 4. If I compare myself with 2, then it will be just the difference. Oh, or I can, of course, remove myself. So I can either remove myself, I can compare myself with 2, or I can compare myself with 4. And then depending on that, I'll just grab whatever it was over here in the DP table. But that wouldn't work because like let's say we actually remove 2. Let's see. I remember what was the problem I was having here. Oh yeah, yeah. Because the problem was like, okay, so sometimes it's actually better to remove. Let's say we have like 1 and 2, for example, and then k is equal to 0. So what we want, do we want to keep 1 and take the difference, or we want to remove 1? And then I was having some problem with so there were two test cases. One where it was better to remove the 1, and the other one was better to keep the 1 and then take the difference, so turn it into 1, 1. And that was a really hard case to catch on my approach because like you don't know if you want to keep the one or keep the two until you reach the end, right? So that would uh we may be able to do kind of like a recursive approach, but that would just not be efficient at all. So yeah, that was why my initial approach was not working. I also tried like also in this approach I wanted to sort the array of frequencies, but I'm pretty sure the frequency doesn't will wouldn't change the approach at all. Okay, so I ended up looking at the solution, not the solution itself, but I saw this comment over here, which was like the best comment ever, which was pretty much a visualization of how to approach this problem, how the algorithm run. He sorted the array, but we don't have to do that. Actually, before looking at this picture, I actually look at the hints. So this part count the frequency of each letter. Okay, that was pretty easy to get to this point. And then suppose we select several characters as the final answer. This phrase over here was like not clear at all for me. Like suppose we select several characters as a final answer. Yeah, I have no idea what that means, but and let X be the character with the smallest frequency in the answer. So yeah, that was so confused after reading this. But the idea is pretty much let me take actually a screenshot of this and wait a little bit. Uh, Let me wait. Let's get the second one done at least. Okay. All right. So the idea was like we we go over each frequency and then assume that that frequency will be the smallest frequency in the whole answer, right? So let's say in this case of the case of two, oops, I'm using oh my gosh. Okay. I'm using white, which is not a good option for this one. Okay, red. Let's do green. So let's say we choose two. So we kind of like assuming that two is going to be the smallest frequency. That's why we have this yellow square above the two over here. So in this case, we're assuming that two is the smallest frequency, and then everything above two that is smaller than two plus k, which is in this case is four, everything here will be valid. And then what I was having a hard time understanding was like, okay, so we're gonna compare two with everything, and then once we get to the next two, we're gonna compare to everything, right? But I was having a hard time understanding like I'm gonna compare two with the next one, so B with K, that passes. Okay, so we're gonna compare with three, and then once I get to five, okay, this is not good anymore, so we need to remove this part. But we checked two with five, but how can I share that two is gonna match three, for example, right? Because after we're done with all this, we're gonna return the minimum value that we found after considering each one of the frequency as the smallest one in the answer, right? So I was having a hard time like, okay, so I compared two with everything, but how can I assure that if B compared to D is okay, how can I ensure that, for example, C will be okay with D as well, right? And then everything comes to idea like, okay, so if I check two with three once, and then I check two with five, it's kind of like I forgot the name of this. There's a name of this, like if A goes to B and then B goes to C, then A goes to C. I forgot the name of this, but we use this in like discrete math. Kind of use this kind of like proof. It was like, is it called Transillion or something with trans? I forgot. But like yeah, so if two is okay, so after compare two with three, if this is okay, when we get to three to five, and this is also okay, then three will also be okay with five, and then everything in the middle also applies for this rule, right? So if go, we compare two with two, and then we compare 2 with 3, and then 3 with 5, blah, blah, blah. These will all also connect. So yeah, this was the hardest part for me to realize. Yeah, so the idea of the algorithms is to count the frequency. I'm pretty sure we don't have to sort it. I think at the beginning of the GIF right here on the answer, it says, yeah, sorting is for visualization only. Okay. Okay, so we're gonna grab for each frequency that we currently considering that's gonna be the smallest frequency on the answer, we're gonna compare it with every other letter frequency. Now, okay, if after comparing, if it's larger, for example, 5, we're gonna remove the difference. So it's gonna be the current frequency. Okay, so we're gonna remove what? Oh yeah, so we're gonna remove the current frequency minus the frequency that we're comparing, takes the absolute value of that, that's equal to 3, minus k, so that's pretty much the extra. So it's gonna be at index I minus index j, take the absolute value of that, and then minus k because this is the tolerance, right? So this case will be 1, which is this red block right here. Now, for the element is smaller than this, okay, yeah, again, we for each element, we're considering that that specific frequency will be the smallest in the answer. So everything smaller than that, we don't want to consider, right? So we pretty much just remove the whole thing. So in this case, we just remove it, 1. And then, yeah, so if yeah, if the frequency of the J that we compare is less than the frequency of the current element that we consider the smaller answer, then we just remove, so we have J right here. Let me fix this. Oops, J right here. We just literally just cut the whole thing. Okay, I think we can start coding that. Yeah, I even have this if name is equal to memory here because I was testing before. So first of all, we need the frequency count. So frequency count is going to be count collections, do collections dot counter, and then we count word, and we're going to do the values. Oops, the values. We don't need to sort this, so we just need to put into a list because it's going to be a iterable. Okay, and then let's see, n is equal to the length of frequency. Okay, for I in range of n, for j in range of n. We're gonna compare. We're considering the n index I as the current and smallest in the answer. So if let's see, if frequency count index j is less than frequency count index I, current is equal to frequency count index I, equals to current. Then let's see. Oh, we're gonna do the DP because we need to track these elements that we're deleting, right? Let me get rid of this one. Okay. So that's gonna be 0, oops, 0 times n. And again, like we only have lowercase English letters, so this is gonna be 26 max, and then there's gonna be all of 26 times all of 26, which is 26 squared, which is still constant time. That's not gonna affect a lot our performance here. Okay, so if comparing something next J is less than current, then that means that we need to remove the whole thing. So dp not deprecated. What? dp index I plus equals frequency count index J. Else that means that's greater or equal. So now we need to check if it's in within the range of tolerance, right? So, okay, so if frequency count index j minus frequency count, oops, no, we didn't do that, current, right? If this, the absolute value of this is less than or equal to k, that means that we're good. We don't need to do anything. So we just continue. Why in the hell is that? Okay, oops, that means that we continue. Else, maybe this else actually. Okay, so the absolute value, oops, like, where's the k? Less than or equal to k. We continue. Else, we have some extra that we need to trim off. So dp index I plus equals. Okay, so it's gonna be this minus k. Yeah, it's pretty much like the red box over here. That's gonna be the actual frequency minus over here minus k. Okay, yeah. Okay, I think that's it. Uh, and at the end, we just return the max of the minimum value of dp. I think that's it. Let's see. Oops, I don't want this right here. Yep. Let's see if you give us submit. There you go. Yeah, pretty efficient because it's going to be all of n in this case, which is we need to iterate through the whole array once to get the frequency, and after that, this is going to be all of one, all of 26 square. But yeah, we don't do this right now. Okay, yeah, I think that's all for this one. Yeah, my first video that was recorded this morning was like 15 minutes long, so this one's going to be way shorter. But yeah, this was like I'm not yes, I'm not sure if I would consider this as a hard question, but yeah, the hardest part for sure was to identify what was the string? Was it this one? Oh no, it was the wait, where's the description, dude? Oh, over here. Okay. Yeah, yeah. Trying to okay, so this approach of considering each element at this as the smallest one in the answer is actually yeah, that part was actually pretty hard, but yeah, I think that's all I have for this one. Appreciate y'all for watching, and I'll see you guys next time.